Earth's orbit is almost a perfect circle, but it is usually drawn using a side perspective that makes it look like an ellipse. Earth's distance from the Sun does vary a bit during the year. Here, Earth is farthest from the Sun at a distance of about 95 million miles. When Earth gets to the opposite side of the orbit, it is at its closest point to the Sun. Here it is about 3 million miles closer to the Sun. So you might expect this part of the orbit to be summer. But think about this. It is winter here when it is summer in the southern hemisphere. We are all about the same distance from the Sun, so that can't be what causes the seasons. Here you can see two beams of sunlight striking Earth. In the southern hemisphere, the beam is striking Earth more directly. The beam strikes the northern hemisphere less directly. You can see the light is spread out over a larger area. So the sunlight heats the northern hemisphere less intensely, and remember also the days are shorter, so it heats Earth for less time each day. It is winter in the northern hemisphere. We call this point in the orbit the winter solstice. It may seem odd, but we are closer to the Sun at the winter solstice. As Earth continues in its orbit, notice that the tilt of its axis doesn't change. The axis always points to the same point in space, which happens to be where the North Star is. So when Earth comes around to the summer solstice, the situation is reversed, with the northern hemisphere now tipped toward the Sun. Now a beam of light strikes the northern hemisphere more directly, and in addition, the days are longer, so this point in the orbit, which we call the summer solstice, marks the start of summer in the northern hemisphere. Down under, the days are shorter and light is less direct, so they experience winter at this time of year. To make this a little more concrete, let's follow Earth back around on its way to the winter solstice and take a look from the ground and see the difference from the northern and southern hemisphere. Here we are looking towards the south from Quebec in Canada. You can see stars rising in the east and setting in the west. That's Orion's belt that's moving along that line, which is the celestial equator, the projection of Earth's equator onto the sky. The Sun rises far south of east, and it never makes it up to the equator in the sky. It stays very low and then sets south of west. So the Sun is not up very long, and it doesn't get very direct sunlight onto the Earth here in northern Canada. Now let's move ahead to the equinox in March. So we'll start the star machine again, and then the stars will continue to rise and set as they did before. What's going to be different, though, is where the Sun rises. It's going to come up due east, and it'll move along the celestial equator, the projection of Earth's equator onto the sky. The Sun therefore goes higher in the sky at the equinox, and then it will set due west. Equinox means equal day and night. The Sun is up for exactly the same amount of time that it is below the horizon. Now let's move ahead to the summer solstice. In June, the Sun is going to rise north of east. And then, because it's going north of the equator, it will take a much higher path in the sky. That's because we're tilted towards the Sun here in the northern hemisphere. Here you do have to worry about a sunburn because the direct rays of the Sun are much more dangerous when it gets this high in the sky. The Sun is up for a very long time in the sky, and therefore the day is much longer than 12 hours. So now let's move to the southern hemisphere. We're going to have to do a few changes here. First, we'll move on this map down to South America, and then we're going to change our landscape as well. Now you'll notice the equator isn't in the south. We have to turn ourselves around and face toward the north in order to see the celestial equator. And then when we start the stars moving, you'll notice something else is different. They're moving, it seems to be in the opposite direction, but stars are still rising in the east and setting in the west. And that's the Sun's path as well. The Sun will rise in the east and set in the west. Because it's June, this is winter time in South America, and the sun is going on its low path across the sky that we now know represents a winter sun.